quantity that has magnitude and direction is called a vector. Vector AB, or vector A. The arrow indicates the direction of the vector AB. The endpoints of the segment AB are called the initial point and the terminal point of the vector. To find the coordinates of the vector AB, we should know the coordinates of the initial point and terminal point. Let the point A have coordinates x sub A, y sub A, z sub A in three-dimensional space, and the point B, x sub B, y sub B, z sub B. So the coordinates of the vector AB will be x sub B minus x sub A, y sub B minus y sub A, and z sub B minus z sub A. So to find the coordinates of the vector AB, we subtract the coordinates of the initial point from the coordinates of the terminal point. The distance between initial and terminal points of a vector is called the magnitude or length of the vector. It's denoted by modulus of the vector AB, or absolute value of the vector AB, or absolute value of the vector A. Any vector whose length is 1 is called a unit vector. A vector with an initial point and terminal point that are the same is called the zero vector. Zero vector. It is a vector whose magnitude is 0. The length of any vector, it is a scalar and must be non-negative, so it is greater than or equals to 0. Let's consider the vector A with coordinates A sub x, A sub y, A sub z. Then the absolute value of the vector A, the magnitude of the vector A, it is the square root of sum of squares of the corresponding coordinates of the vector A. Its formula to calculate the length of the vector A. Two vectors A and B are said to be equal if they have the same magnitude and the same direction. So vectors A and B are equal. Equal vectors have equal corresponding coordinates. To find the sum or difference of two vectors A and B, we should find the sum or difference of the corresponding coordinates of that vectors. To find the product of a vector A by a scalar lambda, we should multiply each coordinate of the vector A by the scalar lambda. Negative of the vector A, it is a vector which has the same magnitude as the vector A, but opposite in direction to vector A. It is vector minus A. If the vector A is vector AB, then vector minus A, it's the vector BA. So vector BA, it is the negative of the vector AB, so it is minus vector AB. Vector minus A, it is the scalar minus 1 multiplied by the vector A. So in this case, lambda is minus 1. The length of the vector minus A equals to the length of the vector A. In general, absolute value of the vector lambda A equals to absolute value of the scalar lambda multiplied by absolute value of the vector A. Let's consider vector 2A. The length of that vector will be absolute value of the number 2 multiplied by absolute value of the vector A, so 2 lengths of the vector A. So I should take 2 lengths and the same direction. It will be vector 2A. The vector 2A will have the coordinates 2A sub x, 2A sub y, 2A sub z. And the vector minus A will have the coordinates minus A sub x, minus A sub y, minus A sub z. If we take 2 lengths of the vector A but opposite direction, we'll have the vector minus 2A. So if the scalar lambda is positive, then vector A and vector lambda A have the same direction. But if lambda is negative, then vectors A and lambda A have the opposite directions. Vectors A and lambda A are parallel or collinear vectors. For example, for geometrical visualization of the vector 1 over 2 multiplied by the vector A, I should take half length of the vector A and the same direction with the vector A. But if we need minus 1 over 2 multiplied by vector A, we should take opposite direction of the vector A. It will be minus 1 over 2 vector A. The standard unit vectors in the plane is 2 vectors I with coordinates 1, 0 and vector j with the coordinates 0, 1. And in the three-dimensional space it will be vector I along the x-axis with 3 coordinates 1, 0, 0. Then vector j along the y-axis 0, 1, 0 and the vector k with the coordinates 0, 0, 1. Any vector A in the plane has 2 coordinates x and y, and we can rewrite its vector as a sum of 2 vectors x 0 plus 0 y, and it's the same as the constant x multiplied by the vector with the coordinates 1, 0, and it is y multiplied by 0, 1, but we can rewrite in the form x, number x multiplied by the vector I, standard unit vector, and plus the coordinate y of the vector A multiplied by vector j. So it is possible to express any vector A with coordinates x and y in the plane in terms of the vectors I and j. It will be x multiplied by the first standard unit vector plus y multiplied by the second standard unit vector j. And in the three-dimensional space where the vector A will have three coordinates x, y, z. So in this case, vector A we can express in terms of the vectors I, j, k. The first coordinate x multiplied by vector I plus the second coordinate y multiplied by the vector j and plus the third coordinate z multiplied by vector k. We call it a linear combination of the vectors I, j, k, the sum of products of the coordinates of the vector A by standard unit vectors I, j, k. The vector A is given with their coordinates, vector A, and our question is how to find the unit vector in the direction of the vector A. So, how to find the vector E with the same direction with the vector A, and vector E must be unit vector, so the length of the vector E must be equal 1. At first, we should find the length of the vector A, and then each coordinate of the vector A we should divide by the length of the vector A, and we'll have the coordinates of the vector E. It will be the unit vector in the direction of the given vector A. So A sub x divided by modulus of the vector A, it will be the first coordinate of the vector E, then A sub y divided by the length of the vector A, and A sub z divided by the length of the vector A. Very small example. Let's consider the vector A with the coordinates -1, 2, 1. So let's find vector E with the same direction with vector A, and the length of the vector E must be 1. At first, we find the length of the vector A. It will be square root of sum of squares of their coordinates. So we'll have 1 plus 1 plus 4, square root of 6. It's the length of the vector A. And the vector E will be with the coordinates -1 divided by square root of 6, the second coordinate, 2 divided by square root of 6 and 1 divided by square root of 6. We found the coordinates of the vector E of the unit vector in the direction of the vector A. We can check our result. The length of the vector E must be 1. Let's find the length of the vector E. It is square root of -1 divided by square root of 6 squared, the first coordinate squared, plus the second coordinate of the vector E squared, and plus the third coordinate squared. So we have 1 squared, it is 1, square root of 6 squared, it is 6, plus 2 squared, 4, divided by 6, and plus 1 divided by 6. And we have 1 plus 4 plus 1, it is 6, divided by 6, it's 1. So we have square root of 1, and it is 1. It is 1. Now let's consider direction cosines. Arbitrary point P in the plane has two coordinates x and y, And let's consider the vector OP with initial point in the region and terminal point in the point P. So the coordinates of the vector OP will be x and y, the same with the coordinates of the point P. Vector OP is called the position vector of the point P with respect to the region. In three-dimensional space, the point P will have the coordinates x, y, z, and the position vector OP will have the same coordinates x, y, z. Let's consider the angles between the vector OP and the positive directions of the x-axis. So the angle between vector OP and the positive direction of the x-axis, let it be angle alpha, and the angle between the vector OP and the positive direction of the y-axis, the angle beta. In the three-dimensional space, we'll have three angles. The first angle alpha, then the angle beta, and the angle gamma with z-axis. Angles alpha, beta, and gamma are called direction angles. The length of the vector OP, or the length of the vector A, is square root of the sum of squares of two coordinates if we have vector A in the plane, and modulus of the vector A in the three-dimensional space, it will be square root of x squared plus y squared plus the third coordinate z squared. From the right triangle OPA, the side OA equals x, AP it is y, we can find the cosine of angle alpha. It will be x divided by hypotenuse absolute value of the vector A. And from the right triangle OPB, we can find the cosine of the angle beta. Cosine of beta, it will be the side y divided by hypotenuse absolute value of the vector A. In three-dimensional space, we'll have the same formulas for cosine alpha and cosine beta, and it is easy to find cosine gamma. Cosine gamma will be z divided by absolute value of the vector A. Cosine alpha, cosine beta, and cosine gamma are called direction cosines of the vector A. In the plane, the angle beta, it is 90 degrees minus angle alpha. So cosine beta will be cosine of 90 degrees minus alpha, but it is sine alpha. So in the plane, cosine of beta equals sine of alpha. And now let's consider the sum of squares of direction cosines. So cosine of alpha squared plus cosine of beta squared plus cosine of gamma squared. It will be x squared divided by modulus of the vector A squared plus y squared divided by absolute value of the vector a squared and plus z squared divided by the length of the vector a squared. And what we can see in the numerator, x squared plus y squared plus z squared, and in the denominator, square of the length of the vector a. But we know that modulus of the vector a, it is square root of sum of squares of the coordinates of the vector a. So modulus of the vector a squared, it will be x squared plus y squared plus z squared. So in the numerator and in the denominator we have the same expression, so it is 1. So the sum of squares of direction cosines equals 1. It is 1. Now let's consider the unit vector in the direction of the vector a, unit vector e. How to find the coordinates of the vector e? We should take the coordinates of the vector a, x, y, z, and each coordinate we should divide by the length of the vector a. And we can see that as a coordinates we have direction cosines. So vector e, the unit vector in the direction of the vector a, has the coordinates cosine alpha, cosine beta, and cosine gamma. In our example, we have found the unit vector e in the direction of the given vector a. How to find the direction cosines, cosine alpha, cosine beta, and cosine gamma of the vector a? So how to find cosines of direction angles alpha, beta, gamma? Cosine alpha, it will be the first coordinate of the vector e, minus 1 divided by square root of 6. Cosine beta, it is the second coordinate, 2 divided by square root of 6. And cosine gamma, it is 1 divided by square root of 6.